All right, guys, we are towards the end of the unit here in graphing lines, and so that means we are ready to do some more like application problems, like word problems, things like that. So I'm going to film those on a worksheet or two, and you can tune in with me that way. Okay, so here we go. All right, guys, we are here, and we are going to be doing a couple of worksheets of examples of real-life applications where we're dealing with lines and graphing lines. And I apologize for all the shadows. The lighting in here is not great, but we'll make it work. Okay, so this first one says, Glenda is draining her bathtub. Her bathtub is filled with 100 gallons of water. Each minute the water decreases by 10 gallons. Okay, so we're told that description. That's kind of the word problem. What we're not given is the equation, okay? But we are given the table of values, and we are also given this graph of the line, okay? So our job is to put in this equation, and we can use any amount of the information that we have, whether it's the word problem, the table, or the graph, to figure this out. Okay, so again, when we're talking about equations, we're talking about y equals mx plus b, right? So that's the format it's going to look like, and we need to find the m value and the b value. The m value, again, remember m for move, okay, but that's also my slope, or where it moves, and the b value is the y-intercept, or where it begins, okay? Again, a couple different ways we could get these two values, okay, but I think looking at our graph, that's what we've done recently, right? The b value is found where it touches the y-axis, right? And we're only shown a small glimpse of the graph. We're only shown these positive values because in a lot of word problems in real life scenarios, oftentimes we don't run into the negative values, so we're only shown this first quadrant, okay? But if you look closely, if you can't see it, there it is. This line touches the y-axis here at 100, okay? So that right there is that point. That point, 0, 100, is the y-intercept, right? We also see that in the table, 0, 100. But then also in the description it says her bathtub is filled with 100 gallons of water. And often, it doesn't say it here, but oftentimes it'll say 100 gallons of water at the start or at the beginning. So those are often context clues that we can use as well. But either way, 100 is the y value. Okay, or the y-intercept, excuse me. Okay, now the tricky part with this is when we dealt with graphing lines before, what we would do is we would go to my point, right? We kind of trace along, and we'd say, oh yeah, there's another point right there, because it goes through a corner, right? We define some clear points, and then we count, right? So if I did that here, and I started at the left, I would say, okay, down to right 1, right? Do you guys see that? It's going down to right 1 each time between each point. So if normally we would say -2 over 1 would be my slope, okay? But the tricky part is with real life problems like this, that only applies when each square counts as the unit of 1, right? And so look at your y-axis. It says 5, 10, 15, 20, right? It counts by 5s. So when I move down 1 space, that's not just moving down 1, that's actually moving down 5, right? So if I'm moving down 2 and right 1, that's how many spaces, but in this scenario, it's moving down 5, down 10, right, and on the x-axis, it does count by 1, so it would be down 10, right 1, okay? So this -2 over 1 is not right, but -10 over 1 would be my slope, okay, or my m value. -10 over 1, or just -10x. So there's my equation, -10x plus 100, okay? And then you can see here in the table too, the table is a little bit confusing. It goes, right, the x value here would be the number of minutes, right? And it defines that up here, x is minutes, y is gallons of water. Okay, so each minute, it goes down by 10 gallons. You might be saying, oh, but it jumps down by 20 there, and then it jumps down by 30. You notice that x values, it skips some of them, right? It doesn't include 3, and then it doesn't include 5 and 6. So it just kind of, because it skips, that's why we see some inconsistencies here. That is the first one, okay? We're going to do one more like that, and then another couple that are a little different. So this guy says, Larry Large starts eating right and exercising. Great. His starting weight is blank pounds. He loses blank pounds each week. Okay. So we're given a lot less information here, right? We're given all these blanks. We're given a partially filled in table. We're given a graph that is completed, okay? But we're not given the equation, and we're not told what the x and y values are. So it's our job to find those. Well, let's start with what we're given here, and let's analyze that. We're given this line, okay, and we are right? We see it starts up here at 325, and then if I look for other clear points, it continues down and down and down, right? Each spot I go down, that's another clear point. But again, don't be confused by that, because the slope isn't going to be -1, right 1, down 1, right 1. It's going to be we count by 5s here as well on the y-axis, so it's actually down 5, right 1. But then let's get into the units here. Let's get into the units that this problem uses, because it kind of describes it for us here in the word problem scenario, and it would make sense to tie that into the graph and then my table and these up here as well. So just thinking logically about this, right, we look at these, and those look as though they are weights, right? Those might be weights, and just reading through this, my 2 units that it mentions is his starting weight is blank pounds, right? And again, I mentioned that starting amount is another word for like the b value, okay, in your mx plus b equation. So it would make sense that if I had a y-intercept of 325, that would be 325 pounds. So let's label that here. So the y-axis, those are going to be all his different weights, okay, that he is as he loses weight. But then how often is he losing weight, right? Because this x-axis is something too, okay? He loses blank pounds for each week, okay? So there's like an amount of time that he's losing this weight. And so that would be in weeks, okay? So I use my context clues to kind of tie that in. So again, tying this in, we can actually get my equation now that I have this. And actually, before I do that, sorry, let's just go into my table. This is actually going to be easier to get right away than the equation, okay? So what I'm wondering is when x is 1, and again that's weeks, number of weeks, and y is pounds, and I'll actually fill that in up here as well now that I have that. It's wondering at 1 week, or when x is 1, what's the y value there? I go up, I trace along, and I see it's that point right there at 320. So when x is 1, y is 320. The next one, when x is 2, y is 315. That's filling in the table, right? You can just get that right from the graph. No calculations or anything required. But then let's go into my equation here, and again the b value is going to be really easy to get here, because that's just the y-intercept. Where does my line here touch the y-axis? That happens at 325, so that's going to be the b value. And then my m value, again, is how much it's moving. And again, if I just counted the spaces that it moves, it would move down 1, right 1. So maybe I would put -1/1. But again, that's only true if each unit, each spot that I move is just 1, but it's not, right? On the y-axis here, it's moving up 5 each time. So as I move down 1 space, that would be down 5 pounds. So -5, and then right 1, and that is actually 1, okay, because that's number of weeks counts by 1. So that would be my slope, -5/1, and then times x, right? The m value always is. Okay, so that is my equation. That's actually the tough part to get, okay? But let's fill in these blanks, just making sure we understand it, okay? So Larry Large is eating right and exercising. His starting weight is blank pounds. Well, starting weight, right? Starting would be another word for that b value, or kind of where the line starts in this scenario. And so that would be that 325 number. And then making this connection, he loses blank pounds each week. So each week, his weight is going down by an additional 5 pounds. That's kind of what that -5 means. It's actually not -5. He loses 5 pounds each week. Okay, so that's what that means there. Just a few more scenarios. Okay, I'll move it in so you can read it at first. But so a hot air balloon is at a height of 100 meters at 2 minutes and at 320 meters at 6 minutes. Find the rate or the slope. The height is increasing in meters per minute. Okay, so this one's a little different. We're not given a graph, okay, but we are given these 2 pairs of values. So in this scenario, it's this hot air balloon, and it seems like it's moving up, right? It's at 100 meters at 2 minutes, okay? And it's at 320 meters at 6 minutes. And it wants us to find the height that is increasing in meters per minute. Okay, now one thing that I should say about the slope, when it gives us this information right here, right? I've said before that the slope is the change in y over the change in x. Another way would say this would be like y, and this is going to sound weird, y per x, like whatever the y unit is, per whatever the x unit is. So I'm tying that into this, right? When it says meters per minute, that tells me that the meters is the y value, minutes are the x value. So just there's 2 separate instances here where they kind of measure the height of this hot air balloon. They say, okay, it's been in the air for 2 minutes. What height is it at then? It's at 100 meters. Okay, Okay, so that would be the point. And a lot of people would do a 100 comma 2 to kind of mark that as a point, but because it tells us minutes is x and meters is y, we flip that around and we say, okay, 2 comma 100, just because it defines that for us. So that's that one instance. If they measure the height of the hot air balloon at 2 minutes, it's there. And then a second time they do that, okay, 320 meters, or at 6 minutes, it's at 320 meters. We would say 6 comma 320. So those are 2 points, okay? 2 instances where they measure this height. And what do they want me to do with that? Well, they ask to find the rate, or the rate is another word for slope, okay? The height is increasing, okay? So it wants me to find the slope, right? If, again, kind of the scenario is, say this was a graph and it was 2 points, right? And those 2 points were connected. It wants me to find the slope of that line. Okay, but obviously I'm not given a graph here, so I'm going to use my alternate version that we learned to find slope, which is that formula, right? y2 minus y1, x2 minus x1. Okay, and so again, first thing I have to do in this slope formula is I have to label my points, right? My values in here. So x comma y, x comma y. And again, these little 2's and 1's just mean, right, the second point gets 2's. That's kind of saying the second x and y values. And then x1 and y1, those get 1's for the first, okay? And so now I plug those values into my formula, okay? So that would be y2 minus y1, so 320 minus 100. Okay, that's the y value subtracted. And on the bottom, the x value subtracted, 6 minus 2 on the bottom. And I actually subtract, so 320 minus 100 would be 220. And then 6 minus 2 would be 4. And then lastly, I actually do the subtraction here, or the division, excuse me. So 220 divided by 4, I believe would be 55. 55, right? And the unit here tells us in meters per minute. So just tying it all together, what is this saying? Well, that's saying that this hot air balloon, based on the 2 measurements that I have, at those 2 different instances, it's basically increasing. Its height is going up at 55 meters for each minute. Last one here. It says use the graph on the right, and it wants me to answer all these questions about it. Okay, so I'm given this graph of all these points. Okay, and the first thing it asks me is what is the slope, and include the units. Okay, so just analyzing this graph. Okay, let's notice a couple things. It's always helpful to look first at how are your axes labeled, okay, your x and y axis. The x-axis is minutes, and so that's a really important qualification to make, because minutes is x, and the y value is gallons, okay? So it wants me to find the slope here first, right? And so it has my points, it doesn't connect them, so I'll do that. And then, so it wants me to count, right? But the tricky part is again, like on my other graphs, this one, normally we would say up to right 1. Okay, this grid's kind of hard to see, but that is just one big space over. So up to right 1. So normally I would say 2 over 1, and a lot of kids do say that, okay? But that's not right, because when I move up by 1 space on the y-axis, I'm moving from 100 to 120. So that's not moving up 1, that's moving up 20, okay? So when I move up to 120, 140, that's moving up 20, okay? 20. So I move up 20, and then I move right 1 space, and before that was just over 1, but here I'm actually moving over, right, each x space over is 10, so I move over 10. So 20 over 10, and this one actually, it's funny, it reduces down to 2 over 1, like it looks like it is, but, and again, a slope is always in terms of 2 units, okay, in a word problem, because it has to do with both. Like up here it was meters per minute. Here, and again, the top number has to do with y, because we counted up and down for that, and that has to do with y. So it's 2 gallons per 1 minute, or another way to write that would be 2 gallons per minute. What is the y-intercept? The y-intercept is right where it touches the y-axis, that would be 100. And what does it mean? Well, it means that, right, that's always my beginning or starting amount. So in this scenario, volume of water in a swimming pool, that would be 100 gallons at the start. And then lastly, how many gallons are at the tank at 40 minutes? And these questions are easy to answer, right? Because, okay, 40 minutes, that's the x value. So you go to 40. So what's the point at 40? That would be 260. Okay, so that is it. Hope that makes sense to you. Some graphing lines, application problems. Good job.
See you later.